Good morning, students. It's the 26th of June. This is Math 2008. We're going to work on 6.4, if I'm not mistaken. Let me double check. Yes, we're going to work on 6.4. We're not doing 6.3 because that's not in the syllabus. With me? Don't email me asking if 6.3 will be on the exam. It will not be. We have done 6.1, we have done 6.2, and we're going to work on 6.4 today. All right. Now, before I do 6.4, a student asked me to do a very particular problem. It's about the tangram, and I'm going to do it first. It is from 6.1. And we'll do it slowly. You have to kind of understand the problem a little bit. Okay. It's how to put it. It's not a very traditional problem. I don't think it's that hard, but it's a I would consider it one of the more challenging problems. Again, thanks to the person who asked us to do it. All right. So we need to find the fraction of each piece. Okay, I'm going to do it one at a time very slowly. Some are easier, some are harder. All right, so let's see. Now, this is A and B. A and B, each is going to be 1/4, right? You can see it. Now, I did draw the pink line. You really don't have to. You know it, right? So I'm going to say A equal to B equal to 1/4. It's the question says, if you read the question, it says the whole square is 1. Pretend it's a pizza or a cake. So A and B must be 1/4 or 1/4. All right. Now I'm going to move on to the right-hand side, this part. Now, how about cutting it further as follows? Now you can probably see. Okay. So what's going on here, guys, is take a look. This this little triangle here is now into 4 parts. This part C, part of G, and D above the line, D below the line. Let's change this line to green. Okay. This green line cuts this triangle into 4 equal parts, and you have to see it. Okay, this triangle and this triangle are the same. This triangle and this triangle are the same. So this was 1/4. Okay. And C has to be 1/4 of 1/4. 1/4 times 1/4, or 1/4 times 1/4 is 1/16. So I'm going to write here, C is 1/16. I'm going to repeat that once again. Okay. I use the green line to cut the whole thing into 2 halves. And what does that mean? Each triangle inside this quarter is 1/4. They're all the same. This and this are the same. This and this are the same. And they're saying if you want to print it and cut it out and then fold it, it'll work. 1/16. All right. Now, D is 2 times C because part of D is same as C. This part of D is same as C. So basically D is 2 times C. 2 times C is 1/8. 2 times C is 1/8. So D is 1/8. That's easy. All right. Now we're going to move forward. Now this one is a little more challenging here, but it's not as bad as you think. Um, this is, we are going to do it like so. We're going to connect these two. And we're going to use a line that's yellow. Look at the yellow line, what it does. The yellow line That's the lower quarter of the square, also into four equal parts. Now, mathematically, you can really show it, but we're not going to worry about it. You need a little bit of geometry. But take a look. This triangle, this triangle, this triangle, this triangle together make this big triangle. And all these triangles are the same size. So after C and D, I'm going to get to E. E is going to be 1/4. E is going to be 1/4 of this quarter. This triangle is a quarter. 1/4 of a quarter is 1/16. I'm just going to say E is equal to C. This will save us a little bit of time. All right. Now look at F. F is same as D. Two triangles, two triangles. So I'm going to put it here. F and D are the same. Got it? Almost done. G is also same as D because D uses these two triangles, G uses these two triangles. They're all 1/16. So I'm going to put G here. I will check your answer. There's a little 1, 2, 3. I have to check it, make sure I did it correctly before I check my answer. So this is 1/8. That sounds about right. This is 1/8. This is 1/8. And that's 1/8, 4/8. Okay, it does work out. I just did it in my head. So the way to test the whole thing, if you add 1/4 times 2, because A and B both are 1/4, you're going to get half. And let me do it here. Okay, half. And your 1/16, you have C and E, you have two of them. That if you add them together, you're going to get 1/8. Okay. And here you have three of them, you're going to get 3/8. You're going to get 3/8. I'll do it here, then I'm going to move it around, okay? I need the rule. You can almost do it in your head. Now, 3/8 and 1/8 is 4/8. Okay? 4/8 is same as 1/2. And 1/2 plus 1/2 is 1. So you have it. We have the problem. These are the answers right here. Um, and I proved it. I didn't mess up. Okay. Now we're going to start 6.4. Okay. 6.4, there aren't too many difficult concepts. It's about proportional reasoning and ratio. I'm going to explain a few things as clearly as possible. Um, what's a ratio? A ratio is denoted as, I'm going to read it, then I'm going to explain it. A over B, or A to B, when A and B are rational numbers, is a comparison of two quantities. So I can say the ratio of the students who were born in Georgia to the students who were born in Florida in a certain class, okay, is G to F. I know there were students who were born in other states, but we are just choosing these two states because these are neighboring states. It was the number of students born in Georgia was 5, not exactly 5. We are going to get to it, 7. Okay, for every 5 students born in Georgia, 7 were born in Florida. Doesn't mean there were exactly 5 students who were born in Georgia. Doesn't mean there were exactly 7 students who were born in Georgia. This is also equal to, if you multiply 5 by 2, you're going to get 10. If you multiply 7 by 2, you're going to get 14. Okay? If you multiply 5 by 3, you're going to get 15. If you multiply 7 by 3, you're going to get 21. So all those scenarios could be possible. Okay. Ratio is the simplest form when you compare two quantities using rational numbers. Generally, we are going to see integers like 5 and 7. Um, they can be rational numbers. There's nothing wrong with it. It's basically comparison of two quantities. And whenever, however you define ratio, the definition remains kind of vague unless you see an example. So you do have an example. And as I mentioned earlier, this section has a lot of good problems. You're going to do some problems, and we're not going to worry too much about the formal definitions. I won't give you how to I won't ask you to define terms, but I'll ask you to do some problems. So what's the proportion? The proportion is basically when we say two ratios are equal. Okay. So the ratio of students born in Georgia to Florida, let's say it's same as the ratio of students born in Alabama to the students born in New York. And so when you set it up as equal, that relationship is called a proportion. Okay. Let me go to a new slide. So suppose we have two ratios. Okay. It's something that we call cross multiplication. I'm going to give you an example. Let's say this proportion is same as x over 5. Let's say this is a proportion. It's two ratios that are equal. Now, what they're really saying here that you can multiply this by this and this by this, and that's relatively easy to see. You multiply both sides by 5. I'm going to show you how to get to this. So you really will see these problems when we are asked to solve for x. I'm going to multiply both sides by 5. And if I do so, this 5 will cancel. I'm going to be left with x. I'm going to multiply 5 times 2 is 10. This is what I'm going to have. Okay. Now I'm going to multiply both sides by 3. If I multiply both sides by 3, I'm going to get a 10 here by itself, and I'll get 3x. Now look what we have done. 10 is really 5 times 2, and 3x is 3 times x. That's all we are doing. It's called cross multiplication, multiplying this by this and this by this and setting them as equal. It's a valid step. We are going to use it. We're going to show you, we won't show you how to do it, but we would kind of assume you know how to do it. All right. So guys, that's all the lecture I have. I'm going to do some of the problems from your book. Okay. I'm going to use, it's a good example to use proportion as we have done before. This example is good. It's a typical proportion problem. Okay. David reads 30 pages of a book in 40 minutes. Okay. In 40 minutes, he reads 30 pages. How many pages should he be able to read in 140 minutes? So when you do problems like this, you really want to define your variable very clearly. Suppose it takes him X minutes to read 140 pages. And I know you'll be taking the exam online, right? But when you teach, you want to make sure your students write they define their variable very clearly. X is what? It's the number of minutes. Sorry, I made a tiny mistake. X is the number of pages. Let's call it X is suppose suppose he reads X pages in 140 minutes. I'm just gonna write mins. Okay, I kind of switched it around. All right, suppose he reads or David reads X pages in 140 minutes. Now, I will set up a proportion. Okay, the number of pages he can read in 40 minutes divided by the number of pages he can read in 140 minutes is going to be 30. That's what he reads in 40 minutes divided by that's what he reads in 140 minutes. And this has to equal 40. over 140. And intuitively, that makes sense. If, if 30 is 1/3 of x, I don't know if it is, 40 should be 1/3 of 140. Okay, that's the basic definition, or that's the basic idea behind proportional thinking. Now I have to solve for x. Okay, so I'm going to show you all the steps, and I will divide this by 10. You can cancel the zeros, or you can say you divide both top and bottom by 10. Divide the top by 4, you're going to get 2. Divide the top by 4, you're going to get, divide the top by 2, you're going to get 2. Divide the bottom by 2, you're going to get 7. Now remember cross multiplication. Based on cross multiplication, we can say 2x is equal to 7 times 30 is equal to 210. Now, you're going to divide both sides by 2. What do you get? You get 105. There is a way you can check this problem if you got it right, okay? I'll show you how to check it, but let's keep it here. And I'm going to check it just to make sure I got it right. So what I'm trying to say is that he will read 105 pages in 140 minutes. Now take a look at it. If he reads 30 pages 40 minutes, he's going to read 60 pages in 80 minutes. He's going to read 90 pages in 120 minutes, so on. So that seems reasonable. Seems reasonable, but I can do better. I can do better. I'll tell you what I mean by better in a second. So I'm going to go back and show you a 30 over this proportion, 30 over 105. That's what we got. 30 over 105 is a small number, 0.28. It's a fraction, sure. And that should match, if I'm correct, of course, 40 over 140. Yeah, that matches. So I don't think I messed up. All right. It's a good way you can check it. So it's a problem from your MATLAB problem. Of course, you're going to get a different number, but here it is. And you want to write your unit. X is, well, number of pages. So your answer will be 105 pages. Okay. You really want to be formal. Okay, let's do one more. Now, the example that I showed you is how you're going to do it using algebra. Your book section also talks a lot about bar diagram, and I'm going to use the next problem to show you an example of a problem that can use bar diagrams. I'll tell you what they are in a second, okay? There are 50 students in a classroom, and the desired ratio of students to computers is 3 to 1. Okay, this is important. The order is important here. Students to computer is 3 to 1. What does that mean? Suppose S is the number of students and C is the number, colon, C is the number of computers. That has to be 3 to 1. That means every computer is assigned to 3 individuals. How many computers are needed? It's a very interesting question. All right, so the way I'm going to do it, guys, the way I'm going to do it, I have 50 students, okay? Uh, Now, there is a little catch here. 50 is not divisible by 3, okay? So what do we do? I have so if my students are, let me make a table to show you, okay? I'm just concerned about the students, okay? I am gonna my the total number of give me 1 second. All right. My total number of students, I'm going to take it and divide it into three parts. Okay. Now, each part would be when you divide 50 by when you divide 50 by 3, you don't get a whole number. You get 16.66. Okay. I'm going to write 16.66. I'm going to explain it to you why. Okay. So, so basically, if you divide your class into three equal parts, each part is going to be 16.67. So theoretically, you need 16.67 computers, but that's silly, right? You can't get 16.67 computers, so your answer will be 17. Answer will be 17. You will need at least 17 computers so that you can guarantee three of the children will have one computer. Yes, there will be a computer that won't have quite enough kids. Okay? Don't say you need 16.67 computers, or don't say you need 16.7 students. When you're talking about things that cannot be in fractions, you round it up depending on the context. I hope that helps. Let's see what else we have. All right, so we have a nice problem here. This is an example from your book, from your text. I, Paulus, and Judy made $2,520 for painting a house. I worked 30 hours, Paulus worked 50 hours, and Judy worked 60 hours. How do they want to divvy up the money? Well, it kind of makes sense to say the ratio is K, Kai, Paulus to Judy is 30 to 50 to 60. Now, when we find the ratio, express the ratio, we express it in terms of the smallest terms. You can divide every number here by 10, and you want to do that. So this is the ratio. Ratio generally is expressed in its simplest form. Now, so I'm going to make a nice little table. Remember bar diagram? Your book emphasizes bar diagram. I'm going to use bar diagram. So let me see what I can do. So this is for J. J is Judy. Okay. Judy gets 6 parts. Okay. Paulus gets 5 parts of the money. They're all equal parts. Paulus gets 5 parts. The other individual, Kai, he gets 3 parts. It's based on the number of hours they worked, and it makes sense. You want to be fair. And I'm going to give him 3 parts. All right, I have it. Now, how much money are we talking about? We are talking about 2,520. 2,520. So I am going to divide 2,520 into all these parts. They're all equal parts. So this is going to be 1, 2, 6 plus 5 is 11, 12, 13, 14. So I'm going to divide that large number, the money amount, by 14. And it's money. I'm going to put a dollar sign here. I'm going to use my calculator. I'm getting 180 bucks if I'm not mistaken. So each box is worth 180. Okay. I'm not going to write them, but you do understand each box is worth 180. Now, how much money does each receive? Of course, Kaulus would receive 180 times 3. Let's go ahead and do it here. 180 times 3, which is 540. Okay. And the next person will receive 5 times 180, which is $900. And the next person, Judy, will receive 6 times 180, well, I'm going to let it pass. I'll try not to delete it. 6 times 180 is 1,080. Now, when you add them up, it's a good idea to add them up. If you add them up, you should get 2,520. And let's do so. This number plus 900 plus 540. We got the right answer. It's a good way to check. So these are your answers, guys. Judy gets 1,080, Paulus gets 900, and Kai gets 540. This is based on the number of hours they put in. All right, guys. We have one more problem that I want to do for you guys. Let's do this one. Okay, the ratio of the eighth graders to seventh graders at a meeting is 4 to 7. So let's do it. 4 to 7. So I need a lot of boxes. 11 altogether. Now, for every 4 8th graders, I have 7 7th graders. So let's color the 8th graders. What color should we choose? Pink. And the 7th graders are going to be yellow. All right, once again, keep that straight. 8th graders represent the 4 equal parts of the class. And the seventh graders represent the remaining 7 equal parts if the class is divided into 7 plus 4 or 11 parts. If 1/4 of the eighth graders are boys and 2/7 of the seventh graders are boys, so 1/4 of the eighth graders are boys, I'm going to put, what should I do here? Let me just do it like this, if you would let me. 1/4 of the eighth graders are boys. Okay? 2/7, this is already cut into 7 parts. 2/7 of the seventh graders are boys. It's a very good problem, guys. What is the ratio of boys to the students at the meeting? All right. This whole thing represents all the students. Okay? 3 of the parts represent boys. So for every, you have to add 4 and 7. For every 11 students, there are 3 boys. Okay? So our answer will be this. If there are 9 boys. Okay. So for every 3 boys, the ratio is boys to students. Is for every 3 boys, out of 11 students, 3 are boys. For every 3 boys, there are 11 students, or for every 11 students, 3 of them are boys. Now, if there are 9 boys in the meeting, what's the total number of students? Well, how do you get to 9 from 3? Well, let's put it here. You can use proportion, but it's not worth it. From 3 to 9, you multiply by 3, so you get 3 times 3, 9. And you do the same with 11. You multiply 11 by 3, you get 33. So the answer is there are 33 students. If there are 9 boys, there are 33 students. Okay, guys, that's all I have for today. Once again, um, do some of the problems, do all the problems from 6.4. If you need help, please let me know. I'll be happy to record a video for your solution. Take care. Bye-bye.